All right, so we are going to jump from timing to RIC benchmarking. And for this, I am happy to welcome Owen O'Donnell, who is Marketing Manager for TerraVM and the Wireless Business Unit at VIAVI Solutions. Owen, welcome. Just a quick note, if you have questions, please go ahead and submit them through the user interface. If we have time, we'll get to them at the end of the presentation. Owen is one of the principal contributors to VIAVI's test suite for O-RAN specs. So pick his brain while you have the chance. Owen, I'm going to pass it over to you.
Thank you very much, Kelly, and thank you for giving me the opportunity to speak today. Actually, this is great for me and for the company. So, yes, RIC benchmarking. Hopefully you can see my slides now, and I'll quickly go through today's topic. So I'm going to kick off just to begin with just a very quick kind of riddle, and that is, what costs $0 to produce, $0 to package, and $0 to deliver, but yet can be sold for billions of dollars? Well, the answer is 5G spectrum. And in the UK alone, $3.3 billion was spent by the 4 mobile operators in the most recent 5G spectrum auction. Now, that's a lot of money for something which you can't see or touch, and that's just for the air or spectrum. When you add to this the infrastructure required to run 5G, that is new radio units, base stations, small cells, core networks, transmission hubs, etc., and then add the services to get the system up and running, tuned and working, the total cost of 5G is in the billions of dollars per operator. So the question is, how can operators maximize this return on investment? Well, the usual ways come to mind: attract subscribers, keep them, encourage them to use the costly services and apps which use data, but also by running the RAN as close to maximum efficiency as possible, keeping it up 24/7, ensuring subscribers always get excellent quality of service, and by getting every last call and data session out of the available spectrum it can. Now, this last point is where RIC comes in, the subject of this session. So RIC stands for RAN Intelligent Controller, and it's an open platform designed to host RAN control application called xApps and RApps, which will be developed by specialist software developers, sometimes external to the RIC vendor. There are 2 types of RIC, a non-real-time and a near real-time. And the main difference between them is the response time they take to affect changes in the RAN. The near real-time RIC will turn around decisions between 10 milliseconds and 1 second, which is practically immediately, while the non-real-time RIC feeds data collected from RAN elements into near real-time RIC and provides element management and reporting. By keeping the RIC an open and standard interface, it fosters innovation and also reduces the time to market for operators. The RIC will become a differentiator for network operators to attract new customers by showing with real stats how their network is outperforming the competition. And as with any new network element, the unknown and risk can be mitigated against by testing. So why are operators keen to get a RIC into their network? Well, it's set to promise a lot of things. Firstly, operators expect to use the RIC to reduce their energy bills without compromising user experience. 2, when network slices are launched, the RIC will help protect them from being impacted by outside elements. 3, it is expected that spectrum efficiencies will happen, providing operators with more calls and data sessions for their scarce spectrum allocation. Number 4, continuous improvement of user experience will be achieved by monitoring KPIs in real time and making adjustments to improve the throughput or reduce the latency. And number 5, the RIC will monitor and observe trends and patterns and anticipate when things may go bad and take remedial action in time to avoid these. And number 6, from a security viewpoint, the RIC will detect data breaches and at the first instance, shut down the intrusion. So overall, there are big expectations on the RIC, and ensuring it goes on to do the job it's expected takes a lot of design, interoperability, and testing. So when it comes to deploying the RIC in a live network, the signs are encouraging. According to a survey of 35 leading mobile operators conducted by analyst Mason, about 1/3 are planning to allow the RIC manage all Open RAN operations, putting huge faith in this new element. Unexpectedly, the top commercial driver for deploying RIC is TCO reduction. And the third statistic here shows that when it comes to how much the RIC can improve the running of the network, interestingly, 3/4 of those surveyed expect between 10 and 30% increase in asset use efficiency. So again, the expectation is there, and now it needs to deliver. Many vendors have already launched RIC products, with new entrants popping up regularly. Mavenir is the latest to launch last month, joining a long list of expected vendors such as Ericsson, Nokia, NEC, Juniper. But we're also seeing field activity, such as the Nokia press release on the right here, announcing a collaboration with AT&T to trial RIC xApps. In the press release, it mentions applications such as Advanced Traffic Steering xApp for distributing mobile traffic across different frequency layers, which frees up more bandwidth for mobile users. But also an anomaly detection xApp, which uses machine learning to quickly detect and classify irregular behavior patterns in the RAN. So coupling these announcements with the many RIC collaborations taking place at the O-RAN Alliance Plugfests, and the RIC ecosystem is showing very good early momentum. Speaking of ecosystem, the players interested in RIC are shown on screen. So equipment manufacturers, these would be RIC equipment manufacturers, they design and deliver the RIC, and they need to follow the O-RAN Alliance specifications to ensure it is truly open and will operate with a RAN of any vendor, while accommodating xApps and RApps from a myriad of app developers. Secondly, operators who are desperate to install a RIC in their network and start gaining advantage of the intelligence it brings, looking to reduce OpEx, as well as differentiate their network from the competition. Then you have labs such as OTIC, which stands for Open Test and Integration Centers. And their job is to ensure the RIC products work, comply to the standards, perform the functions they promise, and interoperate with different vendors. And finally, the app developers. These are made up of traditional telecoms companies, new startup companies, as well as universities and research institutes who feel that they have the design knowledge to create an app which can make an improvement to the RAN. But how do you ensure all of this works in harmony? Well, that's where benchmarking comes in. So 3 types of benchmarking are currently being discussed. There's app benchmarking, conflict mitigation, and app security. And I'm going to go through each one of these separately. So for app benchmarking, this is something operators and app developers will be looking to do. And here's 3 examples of where you might want to do some app benchmarking. So scenario 1 is for an operator to benchmark 2 different app vendors side by side to establish which one works best on their RIC. So say, for example, 2 app vendors claim to have an energy efficiency app, which they say has shown up to 30% energy savings when active. Well, the operator can run each app on its RIC, controlling an emulated version of its RAN and traffic mix, and then observe the output and decide which works best for them. Scenario 2 on the bottom right is more towards the app developer who wants to check if their app works the same in different types of user topology, for example, rural and urban. They need to know how the app behaves with different traffic loads under different coverage scenarios, and then document this and be ready to present it to potential customers. And a third scenario, again aimed at app developers who need to check their app working in the same RAN scenarios, but trying to affect different RAN parameters and see what the outcome is. All of these benchmarkings on screen need to take place in the lab where emulated users, emulated traffic, and emulated RAN scenarios are used to test out the workings without affecting real subscribers. So The second app I was talking about is conflict mitigation, which is other people call it collision management. Remember, a lot of X and R apps will be developed in isolation using RAN feeds to predict and affect the change to improve some aspect of the RAN. But when it comes to a real network running tens of apps making changes, who's to say one change in one direction won't be undone by another app reversing the change? For example, on the left of this slide, we have two apps. App 1 is looking to maximize coverage and will increase antenna power, while App 2 is an energy-saving app looking to reduce power and save energy. So these two apps are in conflict, and if running together at the same time in the same region, could either cancel each other out or cause a flip-flop or of changes going up and down continuously. So in this case, the operator would have a policy which should dictate the winner, but that again might depend on the events or the time of day or the location, etc. And on the right-hand side of this slide is a more tricky conflict to resolve. In this case, App 1 might be reducing antenna tilt to reduce coverage, and then 10 minutes later, a completely separate app decides to decrease antenna power. So different parameters are being altered, but both will have the consequence of reducing the coverage, and this can have quite a big impact on the subscribers. So these types of app conflict will become widespread as more apps get onboarded to the RIC. And again, scenario testing in the lab is where we'll help identify these and come up with mitigation techniques. And the third benchmarking activity is based around security. So there is a huge concern among operators that the background and intent of some new app developers who have no history in the telecoms industry and wondering how well can they be trusted. An app sitting on the RIC is exposed to a huge amount of data from the RAN and has quite a bit of power to influence the running of the RIC, including causing malicious actions. There is concern about apps having a backdoor with hostile software gaining access to network-sensitive data, including subscriber data. So this area needs strong policing. It is envisaged that there will be dedicated security apps which will use AI techniques to detect rogue app patterns, including suspicious behavior, warranting a closer look. Basically like a security patrol app. But benchmarking apps from a security viewpoint is therefore a very high priority for operators and one that they're speaking to us very clearly about. So let me show you one example of a recent and very popular app that's going around at the moment with operators. And it's called Energy Saving, which is getting a huge amount of attention. It's a big topic because 5G networks, while they're more efficient than 4G, they do consume far more power when the true capabilities of 5G are deployed, for example, massive MIMO or 100 plus megahertz channels. And telecom operators are looking for solutions to reduce power consumption. So to do this, the basics they will need to start with are a good understanding of their network power consumption. So putting power measurements and monitoring systems in place. And that can be done via xApp number 1 here on screen. Then a smart methodology and algorithms are required to evaluate the measurements and identify which elements to power down and when. This could be a second app. And then a third app is used to execute the power management actions in the form of instructions to the RAN. So in this slide, we show how this can all be tested safely using simulated CU and DUs and simulated users and cells. Measurements can be directed into the RIC, shown by the red arrow, and these are then consumed by apps 1 and 2. Then once some power saving action is determined by app 3, it will send an instruction, which is the blue arrow, to the RAN, and the changes are implemented in the emulated RAN. Then an app validation engine, AVE here, monitors the results and sees if indeed energy consumption is reduced without degrading user experience. And then these insights are passed back to the RIC as a closed loop feedback, which is the green arrow. So this basically shows a way of verifying an energy saving app in a safe environment. So recently we assisted with a real world energy saving app demo at MWC in February. The demo involved a Juniper RIC, an Era xApp, the VIAVI RIC test tool, and the whole demo was supported on AWS Cloud Platform. The diagram on the right shows the results of the demo. The demo showed how intelligent switching off of cell bands could reduce overall energy consumption while keeping user performance degradation to a minimum. And the demo showed how a 4-site energy saving initiative could save an operator $20,000 per year. Now, if you multiply this up to an average operator's network size of 5,000 cells, that gives an annual saving of $25 million. So this demo, which was seen by huge numbers at MWC, got very positive feedback. And I've included just 2 quotes we heard from senior company executives here. One was from, the top right was from an operator who said, I want this app in my network and this demo in my main lobby. I want to show every politician who's coming to visit that we are green energy and making steps to be fully carbon neutral by utilizing this technology. And the bottom left was a separate reaction, this time from a RIC vendor who said, finally, I see exactly what RIC can give in terms of value to CSPs. So recapping on the questions that operators need answered before they can deploy a RIC in their network. Firstly, how do we ensure the decisions made by the RIC and consecutive changes won't cause a degradation and rather benefit the RAN? Secondly, how do we make sure the AI and ML models are trained and tested in a certain network environment will perform reasonably in different network environments? Thirdly, how do I trust in AI ML models that we don't have 100% control on? How do we make sure they won't cause degradation in network performance? In some cases, we have never had the chance to test. And fourthly, how do we port and combine different ORAN vendors, ORAN components, xApps, ORAPs, and RICs with confidence without concern for network performance and operation? And the answers to all of these questions is through testing and benchmark. Thank you for listening. And now, Kelly, have we got any time left for any questions?
We do have just a couple of minutes, and we did get one question that is, do you see the RIC as the make or break for Open RAN?
I don't see it as the make or break for Open RAN, no, because I think the ORAN components, the CU, DU, and RU, they're all going to do just fine on their own. They're going to be replacements of the full traditional base station, if you like. However, I think the RIC will make the difference to those operators who are deploying Open RAN. And they will be able to take the inputs from those Open RAN components and apply machine learning and AI algorithms to make improvements that will distinguish them from their competitors. So I think RIC is an add-on to Open RAN, which, as I said, it's not going to make Open RAN, but it will definitely give the advantage of deploying Open RAN. Does that make sense?
Yeah. Okay, so I have one other question for you. On your last slide, you talked about the important questions that have to be answered. And one of them strikes me as a particularly hard question to get to for telecom operators, and that's sort of that how do you trust question. How do you think we'll get to a point of trust?
Yeah, that's a very big question. And I think the way in which operators will probably go about it is that they'll probably start using apps which won't be able to make too many big decisions in the RAN, first of all. And energy saving is one, where it might look at maybe powering down an unused cell in order to save energy. And that's something that it won't have a huge impact, because it can be quickly reversed if the users or subscribers' experience is being negatively affected. But it's going to take time for them to trust not only the app developer, but again, Kelly, testing. I mean, the more testing they can do, and this is why we're here today, the more testing they can do in the lab with as many different RAN scenarios as possible means that when they go out into the live, they will have all that under the belt and they'll be able to say, well, we've actually done as much as we can. So we're expecting it to work now and we can trust in what we're deploying. So yeah, it's down to test and measurement as ever.
As ever. All right. Thank you so much, Owen. Really appreciate the time and the expertise. Folks, we are going to move on to our next session.
Thank you very much. Bye-bye.